Hello statistics students, today's learning target is to calculate the expected value and standard deviation of binomial distributions. So when we use our calculator, remember the expected value is x bar on the calculator and standard deviation is sigma. So if you look at the first problem, I completed the chart for you. We have a binomial distribution with 4 trials and the probability of success to be 0.1. So we're going to type that into our data. So on your calculator, you are going to press stat, edit, and you're going to type in the x's in L1 and the probabilities in L2. Then you're going to press stat, move over to calculate, a one variable stat, and you want L1 and L2, and you're going to move down to calculate and press enter. When you do that, you can see x bar is 0.4, that's the expected value, and the standard deviation is 0.6. So for this particular problem, the expected value is 0.4 and the standard deviation is 0.6. Then we could repeat this process, and if you do this again, you will get 2.4 and 0.9798. And for that particular problem in example 3, I did change the probability of success to be 0.6. And then if we repeat this one more time, 4 trials, probability of success is 0.8. And I'm shrinking down the screen so everything is on one page. You're going to see that you get 3.2 and 0.8. Now the goal of this was to figure out, is there a pattern between the binomial distribution, number of trials and success, and the expected value. So let's recap and look at problem number 2. I highlighted in pink the problem. Notice this answer is 0.4 for the expected value. For example 3, 4 trials, probability of success is 0.6. Notice this is 2.4. And in part number 4, 4 trials, probability of success 0.8. And we see that this expected value is 3.2. So what is the pattern between the problem and the expected value? Some of you may have realized in example 2, 4 times 0.1 is 0.4. The number of trials and the probability multiplied together is 0.4. In example 2, the 4 trials times 0.6 gives the expected value of 2.4. And let's see if that pattern continues. In example 4, 4 times 0.8 is indeed 3.2. So what do you notice? You should notice the trials, the number of trials, times the probability is equal to the expected value. And this works if it is a binomial distribution. So scrolling up, I'm going to put that little summary down here at the bottom. So if there are n trials and the probability of success is binomial, p, and this only works for binomial distributions, the expected value is equal to NP, which is the trials times the probability. And that was the pattern that I wanted us to learn, that the expected value is n times p. Let's look at an example or two before we look at the standard deviation. So if you go to the next page here, in this particular problem from the hospitals, the percent dying was 60% and there were 8 patients. So for this problem, the expected value is going to be 8 times 0.60, which is 4.8. So we would expect if 8 patients are admitted, 4.8 of them will pass away. As I said earlier, this is a highly deadly disease. If we look at the example with the phone calls, the expected value, again, is the probability times the number of trials. So the number of trials is 12. The probability of making a phone call is 0.76. So doing that on my calculator, I get 9.12. So what that means is I would expect a employee for every 12 phone calls they make to make contact with about 9 customers. All right, let's go back to the previous page and let's talk about the standard deviation. The standard deviation, which is sigma, is a little harder to calculate. So I'm just going to give you the formula and then show you that it works. So it is the square root of n times p times 1 minus p. And let's take a look at example 4. So in example 4, if I wanted the standard deviation, so the standard deviation would be the square root. There were 4 trials. The probability of success is 0.8, and then 1 minus 0.8. And if you do this on your calculator, you will get 0.8, which was the answer that I'm highlighting in green. And let's just verify it works again. So let me erase this expected value here. So in example 3, the standard deviation is again square root of np 1 minus p. There were 4 trials. The chance of success was 0.6, and then 1 minus 0.6. So doing that on my calculator, if I type that in, 0.4, 0.6 times 1 minus 0.6, and let me show you how to do that on your calculator. So I would do square root 4 times 0.6, parenthesis, 1 minus 0.6. And notice when I do that, I get the same answer as we had with the calculator earlier, at 0.9798. So this is the formula in pink for standard deviation, and in yellow, the expected value formula. Let's take a look at the 2 examples that we did. So if I wanted the standard deviation for the hospital problem, the standard deviation, which we call sigma, is going to be the square root of np 1 minus p, which will be the square root of 8. There were 8 trials. The chance of success was 0.60, and then 1 minus 0.60. So if I were to type that in my calculator, square root 8 times 0.6, 1 minus 0.6, you will get 1.38. And we're going to go 4 decimals. So for the hospital problem, we would expect around 4.8 deaths out of 8 patients. And the typical deviation from the mean is around 1.3. That would mean, realistically, I would expect around 5 people to die from this disease, unfortunately. And then, since the standard deviation is 1.3, plus or minus 1 person in a way. So most days, if you admit 8 people with this disease, you would expect to have probably 4 to 6 people die. Let's do the standard deviation for the telephone call. So the standard deviation is the square root of np 1 minus p, which is going to be the square root of 12 times 0.76, 1 minus 0.76. And again, I'm going to show you how to do that on your calculator. Square root 12 times 0.76, 1 minus 0.76. And doing that on my calculator, I get that decimal, which was around 1.4794. So what does this mean? For the research company, for every 12 phone calls they make, they would expect around 9 customers to be reached, plus or minus that 1.5. So the employee should reach roughly 9 plus or minus 1.5 customers for every 12 phone calls you make. I hope you found this video helpful.